We have two example problems at the top that are worked out, and then you want to work the lower problems. So here's our first example. You have a chunk of metal, it breaks off something, and it has this density, and it has this mass. It can be very helpful to the side to write down the density like that, to make a little column of what you know. And then mass is 2.8 grams. Here's our equation. Density is mass over volume. And he wants to know about the volume. That's the question. We don't know the volume. To solve for a variable, you have to have that variable. It can't be in the denominator. It has to be on top. So we're rearranging this equation so that our v is on top. We multiplied both sides by v. And that gives us d times v is your mass. And then we divided both sides by d. Now our volume is on top and by itself. So then we just plug in our two amounts. We know our mass right here. And then this is our volume. And we get that that is our density. And then we get that our volume is 1 milliliter. Now let's look over here on this other side. You can't find a scale. You want to know how much an apple weighs. You drop it in a bucket of water. The amount of water in the bucket, it starts off at 80. So it starts at 80. And it increases to 180. So notice, we know the volume. We just have to subtract to get it. It's really easy. It's 100 milliliters. That's the volume. And then you find the density online is 0.204 grams per centimeters cubed. And we'll mention this in a minute, but 1 milliliter is always equal to 1 centimeter cubed. So right now we have this equation. We want to solve for the mass, so we're going to get that m variable by itself by multiplying both sides by v. We don't have to do any more steps because our m is by itself. And then we plug in our density, and we plug in our volume, and then we have our mass. Go ahead and solve the next two problems. We're also going to be using density in a different way later on.